Good afternoon, my students. Good afternoon, my viewers. I want to appreciate you for coming back again. We are going to continue where we stop about bearing and distance. And today we shall be looking at a kind of higher example of this bearing and distance. If you're following my video, you will understand where we are coming from, and I would like us to follow so that we'll get this done immediately. Look at this example. It says that a boy starts at A and walk 3 kilometers due east of B. He then walks 4 kilometers due north of C. The question is, find the distance from C to A and the bearing of C from A. Before we start solving this, we will have to appreciate where our A, B, and C will have to fall. Remember, I told you that the second bearing would take its place from the first. What I mean is this. Now, before you place your bearing, you have to be very careful of the question. Look at the question. It says that a boy starts at A and walk 3 kilometers due east of B. Due east of B. Due east of B. Now, it means that, let's say that this is our A. This is your north, south, east, and west. So let us label it to be A. It starts from A and walk 3 kilometers due east. This is the east. Now to that of B. So we'll call this B. And we'll write it north, south, east, and it is west here. So due east, that is how it work. The person walk 3 kilometers. 3 kilometers. All right. Now, he now said that he then walks 4 kilometers due north of C. North of C. So this is north. Due north. So north. So let's call this one C. North, south, east, and west. So this is the north. He then walk. So, and they say it walks how many kilometers? 4 kilometers. All right. Now, if you check this very well, you discover that when you join this together, you have produced a right angle triangle. This is a right angle triangle. Quickly, as a mathematics student, the next thing that will come into your mind is Pythagoras theorem. Since we have here 3, we have here 4. So calculating A will now give us Pythagoras theorem. And Pythagoras theorem says that line AC squared will be equal to line AB squared plus line BC squared. If you agree with me, you discover that line AB is 3. So have 3 squared plus line BC. This is BC, and that will give us 4 squared, and everything there will now be this will give us 9 plus 16, and that will give us what? 25. Now squaring it from here, you now have that line AC squaring both sides will now give us 25. The square root of 25 will be equal to 5. So that will give us 5 kilometer. That is the distance from C to A. Here. That is the distance. So here is equal to 5 kilometer. So that is that. Then what about the B part of it? The B part of it. The B say we'll find the bearing of C from A. All right. In that case, we'll take from the SOHCAHTOA, you have tan theta already is equal to 4/3. And if you solve this, what you have is 1.3 repeatedly in that manner. So get the value of theta. That will give us tan inverse. That will give us tan inverse of this 1.3, and that will be equal to 53.13 degrees, since we are dealing with angle, so it's going to be in degree. Now in this case, now we are looking from C to A. So that will now give us 90 minus the theta we are looking for. That will give us 90 minus, already we've gotten the theta to be what? 53.13, and that gives us 36.87 degree. That gives us 13.87 degree. So that is that about that. So where we are looking for this now is actually the value here. It's actually the value here. This is the value. So the whole of this, remember we said, is 90 degree. So 90 degree, when you subtract it with this theta, that will give us what is going to be here. And whatever you subtract from here will give you. So from this place that we said 90 minus this, it means that this is 36.87. Here will be 36.87. Oh, sorry. Here, this is the bearing. Will be 36.87. The theta already, we have gotten it initially to be 53.13. 53.13 degree. So that is that about that. If you like this, please share it, subscribe, and always visit my YouTube channel for further solving. Thank you.